Hello. Today we will be going over how I created Snake using Python. Now, if you aren't familiar with Snake, who are you and what have you been doing for the last 2 decades? Snake is a classic addictive game that came pre-installed in the most legendary phone, the Nokia, or should I say the indestructible phone, the Nokia. Now, before going over any code, I think we should run the game and just try to get an understanding of the various functionality. You notice I'm in VS Code in a file called main. Let's run the code and just try to figure out what's going on. Alright, the first thing you notice is I get an external screen, and that is a graphic user interface. Apart from that, if you notice in the top center, we have a scoreboard. My snake is obviously constantly moving, and yes, I am controlling it and changing the direction myself. Next, you notice that every time my snake essentially consumes a food object, a new object appears somewhere randomly in the screen. Apart from that, notice, since starting the game, the snake is now significantly larger. There is one more, or should I say two more functionality that we will not observe until we hit a game lose state. And that is if the snake happens to eat itself, it will be a game lose, or if the snake hits a wall, it will also be a game lose. Let me try to get to a score of 25 and then I'll end the game. And up, left, down. I knew it. It's gonna go upright. Ah, upright. No. Up. Has to go up. Yeah, there we go. I think it'll go down. Oh no. Okay. Right. Up left. Yes. And then that's the last one. And I'll end the game now. I'll bite my... No, I'll just hit a wall. Okay, when I hit a wall, there we go. Game over, final score of 25. And once I click on the screen, it exits. Now, if you notice the terminal, I am printing out some output as well as the final score. Let me grab some coffee. I will leave a link to the source code in the description. Install Python, install the Turtle module, choose an IDE of your choice, copy the code, and you'll be able to run and play this game. And trust me, it gets quite addictive very quick. If you notice, we have a folder called Snake Game, and within that folder we have 4 files: food.py, main.py, score.py, and finally snake.py. Let's start off with the most important class in my opinion, that being Snake class. At the top, all I am doing is importing from the Turtle module one of the classes, in this case Turtle. That just gives me the functionality required to essentially create the illusion of a snake. Within my constructor, which is the initialization in Python. No wait, why am I jumping ahead? First, we create a class called snake, which inherits some object. All Python class inherits some object. There's no need for you to specify it here. So you can remove object if you want. It doesn't really make any difference. Now, back to the constructor, which is called the init method in Python. We have 1, 2, 3 members, that being the x coordinate, the y coordinate, and a list called segments. I then create a for loop and I run it a total of 3 times. Within that loop, I create a turtle object. And if you aren't familiar with the turtle library and you may be a little lost, that's fine. I will also provide a link in the description to the official documents that you can go over. Documents are very straightforward and easy to understand. Pen up, all it does is, imagine if you were drawing on a piece of paper and you were moving from one location to another location. If you kept your pen down, you'd create a line as you move. But if your pen was up and you move from location A to location B, there would be no line. And that is why we make sure that our pen is up, so that when we create our snake, it does not leave lines all over our screen. I then set the color to spring green. This is not important. You can make it whatever color you want, obviously except black, because our screen is black. I can then set the position of where my turtle will show up using the set position method, which takes two parameters, an x coordinate and a y coordinate. And starting off, both my x and y coordinates are 0. And if you were to imagine a coordinate system of x and y, 0 and 0 is the center. After that, I immediately minus 20 from my coordinate to ensure that the next turtle is printed on the screen behind the first turtle. And it continues in this fashion, creating 3 squares next to each other that will give the impression of being one snake. I then create 2 more members, Snakehead and Snaketail. Snakehead is the first turtle in my segments list, and Snaketail is the last turtle in my segments list. For some reason, I was doing debugging, so I just have this print statement here, not important. Now, there's this add segment method. As we can see, all it does again is create a turtle. It sets its x and y position to the last segment's x and y position. Essentially, this new turtle will be placed atop the last turtle in our snake segments. So how will it make the snake appear larger? Well, thankfully, due to our move method and the functionality in it, we do this. We say snake at position 0 moves forward. Snake at position 1 will move to where snake at position 0 was. Snake at position 2 will move to where snake at position 1 was. And as we continue in this fashion, it does not matter if we overlay one turtle on another. As long as this method works, our snake will have the impression of being one contiguous unit, from many turtles to one snake. Next, I have a function called detect wall collision. Remember, earlier I had created a snakehead member if its x coordinate is greater than 300. Now again, think of a coordinate system. In this case, my screen is 600 by 600. What that means is the x-axis goes from 0 to negative 300 to the left, from 0 to positive 300 to the right, from 0 to negative 300 from the center to the bottom, from 0 to positive 300 from the center to the top. And that is why if I exceed 300, it means I have gone greater than the size of the screen. In other words, I have hit the border. In that case, I return true. I also return true for the same thing, except this time for the y coordinate. If not, I just return false. I then have self-collision, and what this does is for all the segments in self.segments, starting from the first segment, because there's no need for me to consider the snake head, because if I did, I would always be in collision with myself. I then check if the snake head distance between this segment is less than 5. If so, I return true. If not, I return false. I then take these two collision methods and bind them into one method called detect collision. And its only purpose is to return self.wall collision or detect self collision. If either of these turn out to be true, the function will return true. just due to how OR operator works. And then finally, I have 4 methods, and they alter the direction of our snake. Right, obviously if the snake is not heading left, turn right. If it's not heading right, turn left. If it's not going down, you can turn up. And if it's not turning down, turn up. Wait, did I say that wrong? I think I did. Let's start again. This method. If my snake is not turning right, turn right. But if I have turned right, do not turn left. Why? Because if I were to do so, my snake would immediately consume itself, and that would be a game over. On to left. If I am turning left, I should not be able to turn right, because again, I would be consuming myself. If I am facing up, I should not be able to go down, because if I did, again, I would consume myself. And finally, if I am facing down, I should not be able to turn up, because if I did, I would consume myself. And that's a snake class. Now, I need coffee because my throat's killing me. Alright. Remember, the snake class is just a blueprint for our snake. Next, let's look at the food class. The first 2 lines, you can see I'm importing 2 libraries just to give me access to some very much needed functionality. I then have a list called colors, which is just various colors. It's not very important. You can use it, you don't need to use it, it doesn't really matter. I then do the following. I create a class called food, and I have it inherent from the turtle library. Or should I say the turtle class? So essentially, my food object is now equivalent to a turtle object. And within my constructor, I call the parent constructor by doing the super function. Essentially, it's equivalent to C++ having a child, and then you'd have to call the parent constructor. Let me try to see what that functionality look like. Child, some variables, and then you would call your parent, and you would pass in all the variables here that the parent would define, and then within you would do everything that your child should define. Child constructor. Let me see. Parent. Is that right? Now am I confusing myself? I know this is a tangent, but I am confusing myself. CFS child class calls parent constructor. Let's see. No, I am right. Yeah, you do that. And if I were calling a general parent function, it would be parent resolution scope operator followed by the function name and variables if there are any. Yeah, okay, I'm right. But yep. So that's what the purpose of the super function is. It essentially calls the parent function. In this case, I'm calling the parent constructor. And then below, what do I need to modify? Well, for one, I'm changing the shape of my food to a circle. I'm changing its color to a random color. Again, I have to have pen up because if I didn't, I would be drawing lines everywhere. I set the speed to the fastest so I don't actually have to look at the animation as it moves because that'll be very weird. I then go to, this is equivalent to the position function, it will change where my food will appear on the screen. And I do this by passing in the random.randint value, which takes 2 points, a start point and end point, and picks a value between those two, including the start point and the end point. Now, I did not choose 285 randomly. Remember, my screen is 300 by 300. This ensures that my food object will always spawn within the dimensions of my screen. I then do a shape size method, and all this does is it changes the dimension of my food. And I finally have a method called move. All it does is change the color and then go to a random position. In this way, we only have to create one food object that'll give the illusion of being many food objects. Now, the food class serves as the objective in our game, but also the hindrance, because in the pursuit of the food, if the snake were to hit a wall or hit itself, it is a game lose condition. Now, we move on to the score class, which is very simple. Maintain the user score during the run of the game. Again, we'll import the turtle. We'll create our score class to be a turtle as well. So these are basically the same. We again call the parent constructor. I create another member called score, and I just change some of the default values of my score. This write function, it allows us to write on our screen. Very cool. I then have an increment score function, which does a self.clear, and what that does is it removes all writings or drawings from our object. I'll then increment the score. Rewrite, all that does is it calls the write function. And then I have game over. My write object will go to the center of the screen and I will just print out game over, final score, followed by the final score. And then I have this get score function, which I don't really think I am using. And finally, the main file. Here we bring all prior concepts together. We use those classes, which are blueprints for creating those objects, and we use them to create the needed objects for the game. We also create the screen and run the game. From turtle import everything, this shouldn't be import everything, this should just be import turtle. Which I don't even think I'm using actually. I can remove that. Nope, from turtle import screen. Right, and it all should still work. And then from the snake file, I'm importing snake. From the food file, I'm importing food. From the score file, I am importing score. And I'm also importing the time module, just so that I can maintain, or should I say, reduce the amount of times my screen is refreshed. I then create my screen object. I set its dimensions. I set the background color, and I give it a title and a tracer. I then create 3 objects, snake, food, and score. When I do this method called screen.listen, it's equivalent to C++ Qt Creator that allows it to implement signal and slot functionality. In this case, when I press the up key, the signal of being pressed up will cause the slot of the snake.up function to run. Similarly, when I hit down, down function should run. When I hit right, snake.right should run. When I hit left, snake.left should run. I then play the game. Play the game. Play is set to true, so we're always playing the game. I don't think I'm using counter. Yeah, I'm not using it. While true, screen.update, so again, redraw the screen. I will then sleep for 0.1 second, and then I will immediately begin moving my snake. We check if the distance between my snake head and food is less than 15. In that case, I can say I've consumed the food. I will add a segment to my snake. I will move my food. I will increment my score, and I will rewrite those values. And if at any point I detect collision, play is equal to false and score.gameover. Oh, I am using the getScore function. Okay. And again, we go here and we can run our file and we get a really cool snake game. And let's go. Boom. Game over, final score of 3. And yep, that's it.